Good morning, everyone. Welcome to the EasyPower Tuesday Refresher webinar series. My name is Jim Chastain, an applications engineer here at EasyPower. The primary purpose of this series is to cover a bit more in-depth, specific aspects of the EasyPower tools and some features that may not be covered as often as needed. And today's topic is one of those esoteric subjects that falls into that category. As we're discussing an optional module in EasyPower, which we call SmartDesign. Now, while we emphasize the capabilities to size transformers, cables, buses, and protective devices on the one line, based on the downstream loads, it's nevertheless a tool that's not a magic wand. And in other words, you need to learn a little bit about the basics of its operation to improve your results using it. So again, welcome all. We may be a little bit pressed for time today, so I may not be able to answer questions real time, but please use the question box on the webinar control panel so we can follow up via email. And as we like to do most times, we like to start a session with poll questions to get a little bit of a perspective on the audience's interest level. And I would appreciate some feedback. No obligation or liability, but if you would respond accordingly, and we'll get on with the show. So again, this is an optional module, and as a result, it may not be something that people are driven to without more knowledge about it. And so while this isn't by any means a sales pitch, it does, I think, amplify the versatility of the tool and at the same time, hopefully give current owners or users more insight on how to use it. So let's see how we've replied to this. It looks like we have a lot of people with a need to know. So I appreciate you attending today. And then our second question is, which method of modeling motor control centers do you prefer? And, basically, do you do a discrete modeling on the one line with individual loads, or do you take advantage of the spreadsheet, the data entry using the spreadsheet? So there's trade-offs in these two options. One is you do not have individual arc flash labels when you're using the icon to consolidate loads. And the alternative, when you do it discretely, whereas you would get individual labeling capabilities, you can end up eating up a lot more buses or node count as far as the tool itself. Okay, so it looks like we've got a quorum here. Here's how people have responded. And yeah, as I suspect, a lot of people will do both based upon what they're trying to emphasize as far as the study itself. Well, good. Thank you for sharing that. All right, so as I kind of mentioned, what our agenda is today is this was spawned by a question that came in where a EasyPower owner said, hey, I'm not getting the right results from my use of the SmartDesign tool. And he had a situation where he had both the ability to internally use a spreadsheet entry for loads on a motor control center and then discretely be able to use a motor control center. And he was getting different results by applying the SmartDesign. Well, the point I'm going to be trying to make is that the SmartDesign is not an all-knowing magic wand. It must be directed based upon the guidance that we provide in the setup, plus the way it utilizes the lookup table in the device library. And so all of these elements can be adjusted, and the more we know about that and how it applies to what we're trying to achieve is kind of at the heart of where I'm headed today. So there is a decision tree that follows the one-line diagram, and as I kind of go through this, I don't want to confuse you because we're going to be talking about the device library and making sure we're pointing at the right one when we apply the SmartDesign. And then there's a design catalog that incorporates a decision tree process, and the contents of that is determined by which pointer we've used to set up the database. So all this stuff will be kind of fleshed out as we get into it. So let's go ahead and jump into EasyPower. Let me kind of walk through what we're talking about. So this is a one line that came in, and in EasyPower, I reconstructed it. And what I'm going to do is, because this is a fairly complex situation where we have motor control centers with internal loads and external loads, and some of those are feeding a panel that has certain ratings on it, and we want to be able to apply or size elements in each one of these locations. So what I've done is I've recreated a simplified version just to understand for myself how the tool works. So what I've got here is a step-down transformer, a discrete panel, and a adjustable or motor control, a multi-case circuit breaker, and then a fixed load that's not, and the difficulty in the design was it was a lighting panel, it wasn't a motor. Okay, for starters, I want to make sure I'm looking at the right device library. So if I go into my options and I look at file locations, I can see that the device library setup, in this case, is pointing to a temporary folder or file that I use for sorting things out, in this case, creating the demo. And so I want to make sure I understand that's where I'm making the changes as I go through this process. Okay, so first thing I want to do is just apply the auto design with default setups. If I look at the options, again, under my general setup for auto design, I've selected a specific data sheet or library sheet on that device library. And the reason I've chosen this one is I know it's missing or it's needing the help that is required by this particular problem. So again, I'm selected the part of the system I want to auto design. I incorporate, we call it auto design, and we label it, or we call it SmartDesign and we label it auto design. Pretty clever. Okay, by returning the result, I can go in and look at, what I notice is nothing happened on either one of these elements that I was expecting some kind of activity. So a thing I want to check on is my report. If I go into the windows and look at the auto design report, I see first and foremost that the tool was not able to find the step-down transformer that I'm purporting to use. So let's kind of go back and see what's going on there. If I look at the device library, again, the one specifically that I'm calling out, and I don't want to make a mistake, is this one with the PPE designation. So I open it up and I look at the design area down here under generic 2, which is the one I'm using. If I look at the transformer elements, I see I do not have a 480 to 240 designation. So that means the tool has no way of kind of figuring that out if it's not in its search decision tree. So we're going to set that up as a choice. And the category is going to be 480 to 240. Now, as I do that, I've looked up in my vendor database, and I've got 3 choices here. I'm going to just enter a couple of them, knowing that I may have needs for this capability in the future. So at 10 kVA, it's a 2.9% according to the manufacturer's data sheet. Type is dry. Class is AA. And it works with a fixed 115 degrees C rise. Now I can do the same thing for a 15 Ka just because I have the data in front of me. So it's a 3% dry. And it's worth taking extra time filling this out because it will be there for a long time if I'm going to be doing these kind of projects. Okay, if I had the cost, I could put the cost in, but for now, let's kind of save this and go on and see what happens next. So now I'm going to close this. Now repeat the process. Same pointer to the same device library. We're going to invoke AutoDesign. This time we got a designation on both the breaker and the transformer. Okay, so that looks relatively benign. And it looks like something I would expect. I got a 30 amp breaker for 2.5. Now, what happens if I change this to an MCC? It started out as a panel. So now I go to a motor control center. And on my panel, let's kind of go back here and look. I had it set up for a 225 amp rating. If I go to motor control center, I know for a fact it's set for 400 amps. So let's invoke my, so I'm going to do a Control Z. Control Z, take this away, and go back and change this because I messed it up. All right, so the question is, what happens now for my decision tree if I invoke SmartDesign? Well, I get a much larger frame on my using a motor control center, and it's still giving me a 30 amp selection. So how is this all coming about? Again, I want to go back and look at how the decision tree is working in my device library. So open my device library, and we're going to talk about specifically how the one line walks up the how the tool walks up the one line diagram. So again, I'm using the generic 2 listing. Now we've seen that the transformer now, when we're selecting a 480 by 24, I have a couple choices, and it's picking my first choice for the small load. Based upon that, it'll provide sizing for the cables. The point that I want to look at is what it's doing with my bus equipment. Here for panels less than 250 volts, it's sizing them to the smallest one, and the same is true for the motor control center. But now when I go to protective equipment, I see in my panels I have the ability to use a 30 amp old decay circuit breaker, and the smallest one in the motor control center is 150 amps rated, and still the ability. So the question is, and the case was, in the particular question that came in, why isn't it picking a smaller breaker? Well, the reason is there's not one in the decision tree. And so to fix that, I would want to put in basically the same information that's on this line down here for the panels. And what it amounts to is that the breaker already resides in the EasyPower device library, is just not called out for this particular design sheet. So if I want to add a breaker and I want it to be a generic, this can apply to any manufacturer, but I want to necessarily do it under a different pointer. Let's go ahead and make this 30AF. So now it'll be in the design or the decision path where we're doing this lookup. So let's go back and see what happens now. So the point this isn't a procedure as much as it is a process. So let's go back, and we want to see what it selects when we pick out motor control center, 400 amp rating, but still have a 30 amp, 2.5 kVA load. All right, so invoke AutoDesign. So I'm seeing the same thing, and very often it takes. Okay, so what I'm seeing is that I need to look back at my device library. the decision tree using generic 2 still is hung up on my choice of motor control centers. Okay, now it's matriculated to the top. So the question is, why isn't it picking this particular breaker? So I know it's in the device library, so now what are my other options? Well, now let's go back and look at how the directions are being handed off to the auto design. That's done under the auto design options. Here we're using the right library sheet. Nothing's awry here, but if we go look at protective devices, we're seeing that we're directing it to select based upon the bus rating. What I'd rather have it look for is based upon the load, because that's what we're judging the downstream sizing. So if we go back here and make that selection, undo make sure I didn't change this before I did a Control Z. So I'm still based on the load. So at this point, I've changed the device library design catalog sheet. I want to invoke auto design and generic 2. Yeah, so this is one I'd expect it to be able to handle. Okay, well, at that point, I've still got an issue that hasn't been uncovered. So let me kind of go back to the solution and see what we can determine. If I look at the device library, so I believe on my standard generic 1, I have the solution kind of worked out. So let's see what it looks like. All right, so if I look at, again, generic 1, transformers, I do have a 480 to 240 selection. I do have bus equipment that includes a 100 amp panel and a 250 amp motor control center. And for panels, I have a 30 amp for all loads. And based upon the loads, let's see how it works on this side. All right, so now my panel loading, my panel sizing should end up being all right. Still stubbing my toe on this one. Let's see what I did wrong. Oh, back to the drawing board. Under my setup for auto design, I want to size everything, not just parts of it. So I suspect that's my major malfunction here. Now let's go ahead and look at our report. Okay, it was decided that it had a little over 7 amps. Size the transformer accordingly. In the panel, it's a 225 amp frame or sizing with a 10 kVA transformer feeding it. Okay, under the cable, we show this as a zero load. We need to fix that on panel 1, and there's my problem. So we haven't connected the cables according to the loads that are being supplied. But an overall, looks like I'm attaching my reports one to the other. Okay, so now I'm getting the correct sizing for the panel itself. And the rating is in the device library. If I go back to here, so the reason for the cable errors were I wasn't connecting the incoming as it should be. We haven't. So we're having a standard 30 AF for the main, and then for my load, we're getting a standard 30 AF. So it's sized according to the new rules, the area that I had a problem with to start. And so what I'm seeing is that I'm not recreating the report. Is under my general settings, I have it including the last report every time I upgrade the analysis. Okay, so we solved this a little bit of a roundabout way, but the bottom line is when we're looking at the one-line diagram, it's not a bad idea to simplify the analysis until we understand what the tools are looking at, and make sure we have control over the options. In this case, we were looking at the bus and not the load. We didn't have the checkbox to size everything, so that was a confusing factor. We made additions to the design element tables, and then based upon the elements that weren't available, we expanded the table themselves. And this was only due to the fact that we were dealing with very small loads, and the default setup didn't have that capability set up in the search vector. So the point I'm trying to emphasize is this is a process. It's not a specific procedure that works for all comers. Your system may, and part of the problem is it's the default settings are set for a typical and not necessarily for very small loads as far as EasyPower users. Okay, that was what I was trying to emphasize today. Apologize if that sounded a little bit discombobulated, but it does emphasize the fact that there's multiple options to address between the way the tool is applied and then the reference to the lookup table if we don't have all the elements based upon the expectation of the system itself. Thank you everyone for attending. Hopefully this has been a little bit instructive. Certainly if you've got other questions, you're welcome to contact tech support at easypower.com, or as I say, we'll follow up on the question list via email. Have a good day.